Hello. So I just want us to go over one topic, which is bearing. Look at the basics, just help you understand what it is all about, what you need to know, and what you need to do. So here it goes. So first of all, we'll look at what is bearing, what bearing is. So bearing measures angles. So thus can be the first thing you should understand. Bearing measures angles. So you are measuring how much turn about a point from north. Is made. How much turn about a point from north is made in a clockwise manner. So you are measuring an angle, but specifically you are saying this angle is how much a turn from north. So which means when you are dealing with bearing, everything starts from north. What people might ask, why? If you look at compasses mostly they show, no, they can show other cardinal directions, but mostly they show north. Because once you have north, you know that this side I have the west, this side I have the east, and then this side I have the south. So north is very important because that's how you begin to get your bearings or your directions. So the next thing that you should understand is that north basically here is taken as your zero. Let's look at it this way. If I can ask you turn 90 degrees, you are just seated or standing, I just tell you turn 90 degrees and walk 50 meters. Right, if there's someone who's facing north, they can turn 90 degrees west or 90 degrees east and they walk. And then if there's someone who's facing south also, they can go east or west. If there's someone on facing west, they can go north or south. So if I put these people in one point, let's say I have a point here, everybody stands here, one person is facing this way, the other person is facing this way, the other person is facing, say, this way, and I say turn 90 degrees and walk 50 meters. Each person has two possible options. The person facing north can either turn this way or this way. Then this one facing west can turn this way or this way. And then this one can turn this way or this way. Right. And then we can see that poses a problem, because now we're saying these instructions are not specific. Okay? These instructions are not specific. As you can see, each person will either turn right or left. That's why when we define bearing, we make it clear for two things. We make it clear on two things. One, you are turning from north, and two, you are turning clockwise. Understand? So which means whenever you are trying to define or describe a bearing, first of all, you must face north. That's the thing. And then when you turn clockwise. By clockwise, we mean follow the clock hands, which is this way. So that's what we mean by clockwise. So you follow this direction all round the point. So which means this is still clockwise. This is still clockwise. This is still clockwise. So you are moving in a circular manner like that. But you start from north. So everything starts from north. Next thing that you should understand is that bearing is given in 3 figures. So a bearing of 1 degree is 001 degrees. So if you write this is not allowed. But if you write this, it's acceptable. A bearing of 27, you should correctly write it as 027. So bearing is written in 3 figures. So wherever you cannot achieve 3 figures, you have to prefix by a 0. So that's why this bearing basically is referred to as 3-figure bearing. So the bearing of turning from north in a clockwise sense is called 3-figure bearing. So never give it in anything less than 3 figures. Right. It can also it cannot go beyond 3 figures. Remember, when you go about a point, you do this. This is 360 when you come back. Another 10, another 360, that is 2, that is 720. And another 10, that is 360 plus 720, I think that's 1080, if I'm not mistaken. Right, that would be 1080. So, but still, you are going around the north, the east, the south, and the what? And the west. And some of these angles are equivalent. Remember, when you start from the north, this is 0. But when you come back to complete a revolution, it's 360. So which means basically 0, 0, 0 is equivalent to 360 degrees. And if you go like this and from north you face east, you have made 090 degrees. But if you go again, you have made 450 degrees. So 090 and 450 degrees is still the same. Or what it practically means is you'll be facing the same direction from north. That's what technically it means. Alright, so we will not complicate it. Let's just keep things simple. So bearing should be given in 3 figures, or it should be given as 3-figure bearings. Now, the key thing that you need to understand next is angles associated with the angles associated with directions. Angles associated with the cardinal points. Right, so let's have our north-south line. Once you understand this, now you know that this is given as 3-figure, and you know that it is always measured from the north, and your north is 0. So which means every beginning you are facing the north. At any given point, when someone says 10, 25 degrees, before you start turning, face north first. So basically, your north is your vertical up point, like this one. That's your north. But everyone knows that this way, there is what? East, there is west, and then there is south. So, remember, we are turning clockwise. Once I turn clockwise, I have made an angle of 90 degrees. That is, if I go up and face east, it means if I turn from north, go clockwise, after 90 degrees, I'll be looking this way. If I continue now, that will be another 90 degrees. So the thing is, you should know that between the two successive or the two adjacent directions, there is 90 degrees. So what does that tell us? What does that tell us? It tells us that here at south you have made 180 degrees, which is 90 plus 90. This is 090, and the north is 000. Now if I continue turning, now I'm facing west. I'm facing west. So I've made 270 degrees. And then I continue back. Now I am back north, which means now I am facing this way, and which means now I've made a complete revolution of 360 degrees. Alright, let me remove these arrows because I think they can cause confusion, because they are facing one direction and we are talking of another direction. So ignore these arrows. So just know that you are turning, and now you are facing east. You turn, you are facing south. You turn, you are facing west, and finally you turn, you are facing north again. So where you started, which is 0 degrees, you come back all through. You have now made a complete revolution, which is 360. Why is it important to know these angles? Knowing these angles will help you define what we call it, a proper bearing. Right, so let's look at bearings like this. Let's look at bearings like this. A bearing of 50 degrees, a bearing of 177 degrees, and then a bearing of 249 degrees, and a bearing of 300 degrees. Right, so once you know this, remember we are moving from this point. So if I say make a turn of 50 degrees, you know that, okay, I will turn from north going this way, but it's 50, which is less than 90, so which means it must end before I reach 90. So which means my 50 should be something like this. My 50 should be something like this. So my bearing of 50 will go something like that. So that is the direction you should take if you are describing a bearing of what? Of 50 degrees. A bearing of 50 degrees. Right, next, a bearing of 177. Now you can see 177 is bigger than 90, but less than 180. So it is between these two. It is somewhere here. So understanding the cardinal directions that they have 0, 90, 180, 270, and 360. It helps you to locate the position of a certain bearing. So 170 is between those two. So you know that, okay, 177 is closer to 180 than 90. So your bearing can come something like this. You see, you can come up with your 177 like that. So this will be a bearing of 177 degrees. You come to 249. 249 is between 180. It's greater than 180, but it is less than 270. And you can pinpoint that, okay, it is somewhere maybe there. You can come up with it like this. I'm trying to see. It is from 180, it is 60 something. Yeah, it can come out something like this. So that will be a bearing of 249 degrees. And finally, the bearing of 300, it is between 270 and whatever. So your line can come anywhere there. So you can have your line coming in at this direction. You can have your line coming in like this. The moment you know that this angle is between these ones, then you can map your direction very, very easily. So understanding the cardinal points will always assist you in this endeavor. So the point I just explained here is that knowing each cardinal direction with its associated angle, when we turn from 0, which is the north, in a clockwise sense, helps you understand where to put any bearing that you are given, because you can find that, okay, it is between 180 and 270, so it comes here. If it is between 90 and 180, it comes here. If it is between 0 and 90, it comes here. And if it's between 270 and 360, it comes here. You don't talk of between 0 and 180, because between 0 and 180 there is 90 degrees. So you always position the angle in 90-degree intervals. Alright, so what we're going to do now is we'll move on, and now we will be trying to draw bearings using distinct or separate diagrams to show the understanding, and then I'll give you your own to try and see if you've understood the concept. Alright, let's say the question is represent the following bearings. We will give them some distances. Alright, A, okay, 6 kilometers on a bearing of 80 degrees. B, 20 kilometers on a bearing of 290 degrees. And C, 15 kilometers on a bearing of 100 degrees. And then D, 10 kilometers on a bearing of 200 degrees. Alright, so let's look at these four. So, in every situation, you start with your north. Right, you can start with your north like this, and then just put your horizontal line for the west, for the west and east. You can do whatever you want, or whichever way that helps you understand better. So start with the north, and then you make the horizontal for the west and east. So this is my north, which is my 0. So I'm saying this is where I am facing first before I do anything. So now I want to make 6 kilometers on a bearing of this is not correctly written, it's supposed to be 080 degrees. Right, 6 kilometers on a bearing of 080 degrees. So we know that this is east. And how many degrees is east? East is 90 degrees. So 80 is before 90 degrees. So 80 is before 90 degrees. So which means my line should be between north and east. And the 80 is close to 90, so I can draw my line like this. Remember, this is not to scale. We are not required to measure at this moment. In some cases, you can be required to measure, of which you should do, but at this moment, no request for us to measure. So we can come up with the diagram like this. And then the angle which is 80 degrees, since we measured, this is our 0. This one is the angle which is 080 degrees. That's the angle which is 080 degrees. And then that's your final position. And then this distance is the one which is 6 kilometers. You understand? That's this distance, which is 6 kilometers. Part B now, they are saying 290 degrees. Remember, this is your east, which is 90. This is your south, which is 180. This is your west, which is 270. So 290 degrees is bigger than 270. So it means I've gone 90, 180, 270 plus 20 more degrees. So it means my bearing should come something like this, which means I am going this way, for a distance of 20 kilometers. So maybe I can make my line a bit longer. That's why I don't like joining lines at midway, because the line will be very clear that it was joined anyway. Right, so this whole angle is 290 degrees. That's the angle which is 290 degrees. And if this is 290 degrees, everybody knows that 360 minus 290, this will be 70 degrees. This will be 70. But I'm not going to write 070 because it is not a three-figure bearing, because this one is now measured this way. So this is our 290 degrees, our three-figure bearing, and that is 70 to make it 360. And then this is your final position, and then this is 20 kilometers. So this is not to scale, so there is no problem. And here I'm just showing how you pick your direction. Right, next, C is 50 kilometers on a bearing of 100. Okay, so there is my cross for west east. That helps me to pick my angles very well. And this is my north. You see, every diagram I start with the north. So we will go 100. This is 90, and this is 180. So where is 100? 100 is just after 90 by 10 degrees. So which means our 100 comes out like this. Okay, this is not to scale, so there is no need to have your line measured so much. Here it is just about to show, and this distance is what? Is 15 kilometers. And this whole angle measured in a clockwise sense is 100 degrees. So that's how we go. So you can see that clearly the 100 degrees is beyond 90 degrees. So if you come up with 100 which is before 90 degrees, your diagram is wrong and you are picking a wrong direction. And finally D, we are picking a bearing of 200 degrees. So let's see, there we go, we start there, and then we make our, this one will always help you because you will know whether I am still below or above 90, or I'm still below or above 180 or 270. Here we go. So I start with the north. As you can see, all my 4 diagrams I started with the north. That's what you should do. This is C and this is D. Right, so here we go. 200 degrees, this is 90, this is 180. So where is 200 degrees? 200 degrees, obviously it is above beyond 180 but less than 270. So we expect it to be something like there. Forgive my line. So there we go. 200 is closer to 180 actually. So it can come up like this. Just trying to be a bit reasonable. So we're saying this whole angle is what? Is 200 degrees. That whole angle is 200 degrees. So 200 degrees represents everything. So you realize that at a later stage, someone who's very conversant with this will not need to draw the whole, they will not put the south, they will not put the east, they will not put the waste, but you will see them coming up with 200 in something like this, because they will be seeing that it should go this way. When you say a bearing of 300, you see the person just going something like this, just automatically. So as you learn this, make sure you work it out in your head to notice where is 180, where is 270, and where is 90, and my 0 is the same as my 360. So when someone says 250 degrees, I know it's more than 180 but less than 270, so I go this way. So it means you've been an expert at that point. So what I'm going to do is, now I'm going to give you your 4 that you're going to do by yourself to test your understanding, then we'll move on to the next thing. Right. I'm not going to do the solutions for this one, so this one is on you. Alright, so try to do those 4 and test your basic understanding of mapping out bearings. If you didn't understand, you can replay the previous part and catch on and then move. Right, now let's take things a little bit further, whereby we will be trying to work out some reverse bearing. We'll be doing the same thing. So now we'll be working a reverse bearing. This is just playing with words, but it shouldn't confuse you a bit. It's something very simple and straightforward. The questions look like this. B is on a bearing of 0.70 degrees from A. What is the bearing of A from B? Right, so now we're looking at something very different. Look at this. Bearing of A from B. Here we are given bearing of B from A. So we are given 0.70 from A. So which means our starting point is what? Is A. So this is where now we are working a little bit. So we position A. There we go. This is point A. I don't like the clumsiness on the board. Good. So where is point A here? Point A is there. That's our point A. okay, and then B is on a bearing of 0.70. So from our previous work, we now know that 70 is greater than 0 but below 90 degrees. So you know that this is your north, so don't draw before you have this, unless you are now an expert. So the direction of B will come something like this, and then this will be my 0.70. I believe right now this shouldn't come as a shock. It's something that we understand, because we're measuring from north going in a clockwise manner, and 70 is less than 90 degrees, which is the direction of east. So that's why this line goes there. And then after some distance, we have point B there. Now, the question now says, find the bearing of A from B. So basically now we're saying we are at B, which means we're turning from the north of B. So whenever the question now says the bearing of another point from B, go to B and mark the what? The north. Go to B and mark the north. That's how you go. Go to B and mark the north. And then, so the question is simply saying now, with your north of B, turning clockwise until you touch this line, or until you are now facing A, because if you touch this line, it means now you are facing A, like this. So this is the angle that we want. What is that angle? That is the question now. So this is your point B. This is your point B. So the question now is saying, what is the bearing of A from B? So what we do in this case, right here, this is where now you bring in the concept of parallel lines. Bring the concept of parallel lines. That's the beauty of math. One or the other concepts borrow from one another, or they help each other. So if you start working with parallel lines, you will unravel the whole mystery. So bring in the parallel lines. So when you say bring in the parallel lines, now we start talking about alternate angles. Start talking about alternate angles, corresponding angles. Start talking about co-interior angles. Right, what is parallel? This is north-south, and this is also north-south. So basically, the north-south lines, they run in the same direction, so which means they are parallel. So we remember the concept of Z angles, or alternate angles. So if your parallel lines are like this, you can see that this angle is alternate to this, and I believe by now you can see where I'm arriving at. It means this angle, by the alternate angles concept, is what? Is 70 degrees. And as now we want the whole angle like this. And we know that from the north of B up to the south of B, that's 180. So it means the bearing now is 180 plus 70. So we can now say the bearing of A from B is 70 plus 180, which is 250. We don't say 250 because that will be 4 figures. So 250 is 3 figures, so it is sufficient. So the bearing of A from B will be 250. So that's how we find the reverse bearing. That's what we mean by the reverse bearing. When we are given the bearing of A, of B from A, we'll try to find the bearing of A from B. So let's look at another question. Try to consolidate the concept. Maybe 2 more questions. The bearing of X from Y is 280 degrees. Find the bearing of y from x. Let me use another number here. If I threw that one away because I noticed something. Let me say 120 degrees for now. So the bearing of y of x from y. So since they said from y, we start by finding the position of y. Finding the position of y. Right, so there is our y, and this is the north. So that's y, and then this is 120 degrees, and we know that this is 90 degrees, this is 180 degrees. So 120 is between these two, so it means the line should come something like this. Okay, right, so that's where our x is. That's where our x is. Since we are going to find the bearing of y from x, obviously we need to put the north again, the north of x, like that. There we go. Now the bearing of y from x, we are measuring it from the north of x. From the north of x going in a clockwise sense. So we want this angle, this whole angle. And we can see that once we find this angle, this one, we can subtract it from 360 and we will find our bearing. Now let's come here. We said this is 120. The 90 is, this is the 90. So this is the 90 in the easterly direction, so don't get confused there. And this whole angle, this one that I traced here, that's 120. Now what is left to make 180? Because up to here is 180, so up to here is 120. So what is left to make 180? Right, work it out. Okay, so I know you found it correctly, and it is what? This is 60 degrees. Now let's go back to what we discussed, alternate angles. This angle is alternate to this one, which means this one is what? Is 60 degrees. So which means this one now will be 360 minus 60, which is what? 300. So it means the bearing of y from x is 300 degrees. So don't get confused. What you need to do is don't try to come up with a formula or a system. Draw your diagram. Your diagram will tell you what is going on. Once you draw your diagram, you are set. So you draw your diagram. Once you draw your diagram, trace the angle you want. Trace the angle or the bearing you want, and then work it backwards from what you already have. Utilize the alternate angles, the corresponding angles, or whichever is available. You can use any. You can even use angles in a triangle if you want. All right, let's look at question number 3. Let's look at question number 3. The bearing of C from D is 290 degrees. Find the bearing of D from C. You see, we start with from D, C from D, then now D from C. So anything from D, we go to the position D. Anything from C, we go to point C. So which means, since we are given bearing from D, we come up with point D first. We come up with point D first. There we go. So where the lines cross, that's your point D. So this is D. So don't get confused there. This is point D, and then this is my north for D. And the bearing is 290. Remember, this is 90. This is 180. This is 270. And we are going clockwise. So it means we go 90, 180, 270. So for 290, I need to still go, so which is this way. So it means my direction for C will be something like this. So there we are. So then at C now, we need to mark the what? The north. We need to mark the north. Remember, I told you, create the angle you want first. So this is point C. So we want the bearing of D from C. So we come here, we want this angle, which is the 10 from the north of C until we face D, or until we touch the line joining C and D, or we touch the line DC. Okay, so let's work out everything now. Remember, we said this is 290. This is 290. If this is 290, what remains to make 360? Good. You found 70 degrees, so which means this is 70 degrees. If that is 70 degrees, this will also be 70 degrees. Why? Alternate angles. So this is 70 degrees. So our bearing here will be 180, because all the way from here to here is 180. So our bearing will be 180 minus 70, which is 130. So it means bearing of D from C equals 130 degrees. Okay, so that's the bearing for D from C. So you can take time again to go back and start afresh, get things step by step, because what I'm going to give you now is 3 questions for you to practice as well, just like the first instance, so that you can work this thing in reverse. So okay, so there is the question. The bearing of B from A is 200 degrees. Find the bearing of A from B. So you can take a moment, go back and see how we did the first ones, and then from there try to do this one on your own. I believe it will be easy. And once we have done that, look at some questions of the same nature and then attempt them, and that will solidify your understanding, or your basic understanding of bearings. So this is video part 1. We are going to do video part 2, where we'll be continuing beyond just one line, where we'll be using bearing to draw triangles, even quadrilaterals, and then from there solving for some distances, as well as solving for some angles and more bearing as well. Alright, so this is the end of our video. I hope it helps you. Take care.